Thank you everyone for your interest in our project, Intelligence for Existing CCTV Systems, developed by the ROC-Dragon Team. In this video, I'll demonstrate how to use our web application. On the homepage, you'll see the CCTV Monitoring AI dashboard. Here, all registered CCTV cameras are displayed, showing the current live view from each camera. Our AI also performs real-time object detection, recognizing more than 80 different object classes, including people, cars, chairs, sofas, bicycles, dogs, cats, and many more. Besides the live monitoring page, our platform includes 4 main modules: camera graph, playback, investigator, and tracking. Let's start with the camera graph. Instead of relying on a traditional building floor plan, our system represents the relationship between cameras as a graph. Each camera is connected using descriptions of the camera itself and the pathways between cameras. All of these descriptions are automatically generated by a vision language model, such as Gemma or Anthropic Claude. For each camera, you can specify which floor it belongs to. You can also connect cameras by clicking the chain icon. The same button is used both to create and remove connections between cameras. You are free to choose which vision language model you would like to use. Each camera periodically captures images, and the selected VLM generates a natural language description of what the camera is observing. In other words, it translates the visual scene into human-readable descriptions. Once every camera has been described, we use an LLM to understand how different cameras are related to one another. The reasoning is guided by the camera graph that we created earlier. After every camera has been connected, the system can infer the semantic relationship between different locations. For example, it understands that a storage room is connected to a parking area, which then leads to the building lobby. You can also manually add your own descriptions to improve the accuracy of the system. This camera graph is an important knowledge base that allows our AI agents to understand the relationships between cameras throughout the building, enabling more accurate reasoning and better decision-making. Next, let's move on to the playback module. Unlike a traditional CCTV playback system, our playback page includes AI agents that help you search for events much more efficiently. Instead of manually browsing through hours of video, you can simply ask the agent what you're looking for. For example, you can ask, "When did a person interact with a dog?" The system searches through historical recordings, identifies relevant events, and provides a list of interesting timestamps together with a brief summary of what happened. By clicking on any timestamp, the playback automatically jumps to that specific event. Whenever you pause the video, the system analyzes the current frame and generates a description of the scene. An analysis agent then examines the situation in greater detail. A supervisor agent provides recommendations on what actions should be taken next and also checks nearby cameras for additional information that may assist with decision making. If you prefer the traditional method, you can simply use the timeline at the bottom, just like a standard CCTV playback system. Let's look at another example. Suppose we want to know whether there was a crowd gathering near the parking entrance. We can jump to one of the suggested timestamps. Here, we can clearly see a group of cyclists visiting the area. When we pause the video, the system immediately analyzes the scene, explains what is happening, and provides recommendations based on the current situation. Now, let's move on to the investigator module. You can think of this module as an intelligent chatbot that helps you search through information collected from your CCTV system using various AI tools. Let's look at the first example. If you're not familiar with the building, you can simply ask the system what this CCTV network is monitoring or what this location is. The system will answer with information about the location. You can also ask the system to list all available CCTV cameras. This makes it much easier for new users to understand the layout of the building. For example, you can ask what is currently happening at the rear entrance of the building, or you can ask about the current situation at the front gate. You can also search for historical events, such as asking who walked through the front gate at 8 a.m. The system describes individuals based on their appearance, such as their clothing and outfit. To protect privacy, the system does not identify people by their faces or other biometric characteristics. If you're interested in a particular anonymous individual, you can ask the AI agent to investigate where that person went, whether their activities were related to building security, or which cameras they appeared in. Let's look at another example. Suppose you're wondering whether any dogs or cats have entered the building. You can ask the system to show statistics of dog activity at a specific location, such as the front gate. Based on historical data, the system may indicate that dogs usually appear around 7 o'clock in the morning or around 1 o'clock in the afternoon. You can then request evidence for those time periods. If no dog appeared at that exact time on a particular day, that's perfectly normal since statistical trends do not guarantee that the same event occurs every day. In that case, you can search directly through the recordings from that specific day. The system will locate the relevant evidence and display the corresponding video on the right. This can help identify stray animals entering the property or confirm that the animal belongs to someone and does not present a security concern. Let's look at another example. Suppose we want to find the parcel storage room. You can simply ask where packages from the postal service are stored. The system identifies the correct area used for parcel storage. You can also request statistics about motorcycles passing near the parcel room. Even if there are no events on a particular day, you can still ask when parcel deliveries are most active. The system answers the question and presents CCTV evidence on the right-hand side. You might wonder how the system knows all of this. Our platform combines vision, language models with object detection to generate descriptions of events captured by CCTV cameras. These AI components work together as a pipeline. Finally, let's look at the tracking module. This module focuses on tracking people across multiple cameras. In this example, I selected a delivery worker. People are categorized based on their clothing and appearance. The system can describe what this person was doing, which cameras they appeared in, and which areas of the building they visited. In this case, the records show that the person was primarily delivering parcels. These activity records are generated using the Gemma 4 vision language model. The system also supports searching by global ID, which is generated using appearance-based person re-identification. You can search for individuals using descriptions such as a person wearing a green shirt, or search directly using the assigned global ID.